Hi, hi students. In today's class, we are going to discuss the trigonometric chapter problems which are given in SA1. Okay, in SA1, what are the trigonometry related questions that we are going to discuss? So it is paper 2 in SA1 mathematics, paper 2 it is. Mathematics paper 2 we have. In the paper 2 we have, that is section 1. Section 1, paper 2, section 1 of SA1, that is problem number 2. It is given. What they have asked is, show that, write the sine theta in terms of tan. Sine theta in terms of tan theta. Okay, so for this we know sine theta we can write it as 1 by cosecant theta. Sine theta we can write it as 1 by cosecant theta. And we have the relation between cosecant theta and cot theta. We know that 1 plus cot square theta is equal to cosecant square theta. This we know the relation. So from this we can write, if you take square root on both sides, if we take square root on both sides, we get square root of 1 plus cot square theta is equal to square root of cosecant square theta. On the right hand side we can cancel this square and square root, so we have it as cosecant theta, which we can write it as 1 by sin theta. Already we have written sin theta is equal to 1 by cosecant theta. We can take it as equation number 1. And this we can take here LHS of this 1 root 1 plus cot square theta is the LHS, and we can give this as equation number 2. So we are going to substitute equation number 2 in equation number 1. That is, in place of cosecant theta of equation number 1, we are going to substitute square root of 1 plus cot square theta. So LHS we have sin theta is equal to, in place of cosecant theta, that is denominator, we can write root 1 plus cot square theta. And we know that cot theta, or you can write we have that, or we know that cot theta is nothing but 1 by tan theta. Cot theta is 1 by tan theta, that we are going to substitute. So sin theta is equal to 1 by root 1 plus 1 by tan square theta. If you take the LCM here, in the denominator, if you take the LCM, we can write it as tan square theta will be the LCM, and here 1 by 1, so we get 1 into tan square theta, we get tan square theta plus 1. So this complete term we have in the denominator, this one. So when we take this in the numerator, we can write it as reciprocal of this. So we get it as root tan square theta divided by 1 plus tan square theta. So in the denominator we have 1 plus tan square theta, that we can write it as, okay, because they've asked to write in terms of tan theta, so we're going to keep it as 1 plus tan square theta only. Okay, so this is, finally we can stop here that sin theta in terms of tan theta they've asked. Further we can write like root tan square theta divided by root 1 plus tan square theta. In the numerator, square and square root we can cancel, so we left with tan theta divided by root 1 plus tan square theta. This is how we can write. This is writing the sin theta in terms of tan theta. Another problem number 6 they have given, that is section 1 problem number 6. They have given cot 35. They have given it as cot 35 and represent this cot 35 degrees within an angle of greater than 35. So cot 35 we can write it as cot 90 minus 55 degrees, and cot 90 minus theta we know that it has tan theta. This is the formula which you have to remember. Cot 35 we can write it as in terms of tan 55. Okay, cot 35, first it is written as 35 is taken as 90 minus 55, and cot 90 minus theta is nothing but tan theta. Right, this is with respect to section 1. Next we have section number 2. Section number 2 problems. Problem number 9 in section number 2. This is for 2 marks. 2 marks. So what they have asked is show that secant theta minus tan theta square is equal to 1 minus sin theta divided by 1 plus sin theta. This is what they are asking to show that. So we can start with, in this type of problems where they ask show that or prove that, we can start any one of right hand side or left hand side and we can solve. So here we are starting with right hand side, and in place of secant theta minus tan theta square we can write 1 by cos theta. For secant theta we can write. This problem number 9 we have RHS is equal to 1 minus sin theta divided by 1 plus sin theta. So this we are going to multiply numerator and denominator with 1 minus sin theta. Why 1 minus sin theta we have to choose? It is in the denominator of this RHS we have 1 plus sin theta. So to simplify this we are going to multiply with opposite sign of the denominator, that is we have 1 plus sin theta, so we are multiplying and dividing with 1 minus sin theta. So this is like if you multiply 1 minus sin theta by 1 plus sin theta with 1, there will be no change in 1 minus sin theta by 1 plus sin theta, and in place of 1 we are writing it as 1 minus sin theta by 1 plus sin theta. If you cancel we get it as 1 only. Suppose if we cancel these two we get it as 1. Okay, so here it will not have any effect, that is if you multiply with 1. So we write here 1 minus sin theta whole square divided by, in the denominator we have 1 plus sin theta and 1 minus sin theta. 1 we take it as a, sin theta we can take it as b. So we have a plus b into a minus b. We get it as a square minus b square. So we get it as 1 square minus sin square theta. In the numerator we have 1 minus sin theta whole square. In the denominator we have 1 square minus sin square theta. It is 1 minus sin square theta which is nothing but cos square theta. We get it as cos square theta. Since here for numerator and denominator powers are same, 2 we have, so we can combine it as 1 minus sin theta divided by cos theta whole square. So 1 minus sin theta by cos theta. Now we can write individually for 1 as 1 by cos theta minus sin theta by cos theta. That is, denominator cos theta is written as individually for both 1 and minus sin theta. We know that 1 by cos theta is nothing but secant theta minus sin theta by cos theta, it is nothing but tan theta whole square. Already we have. This is nothing but our LHS. So that is what they have asked. So LHS we got we started from the right hand side and we got it as LHS equal to LHS. This is how we have to do. So this is nothing but LHS. Hence it is proved. Hence it is proved. Next we have problem number 12 of the same section. What they have asked is, if secant a plus 15 degrees we have is equal to cosecant 2a, and where 2a is an acute angle, where 2a is an acute angle means less than 90 degrees acute angle, then find the value of a. That is what we have to find. So what is the question they have asked is, secant a plus 15 is equal to secant 2a. So we have the formula that we know, secant 90 minus, we know that secant 90 minus theta is nothing but cosecant theta. So here in the given problem, RHS here we have, RHS is cosecant 2a. So in place of theta we are going to write it as, 2a. So secant 90 minus 2a is nothing but cosecant 2a. So we are going to now take the equation which is given. What is given we have? Given is secant a plus 15 is equal to cosecant a, and cosecant a can be written as secant 90 minus 2a. Now both LHS and RHS we have, secant we have, and in the brackets whatever we have we can equate this. So a plus 15 degrees is equal to 90 minus 2a. We can equate the values in the brackets. A plus 15 equal to 90 minus 2a. Now we are going to bring this minus 2a on the left hand side and 15 degrees on the right hand side. So minus 2a, when it comes on the left hand side it becomes plus 2a, and plus 15 degrees when it goes to the right hand side it becomes minus 15 degrees. So we get 90 minus 15. 90 minus 15, it is 75. A plus 2a, it is nothing but 1a. 1 plus 2, 3. A remains the same. So 1a plus 2a is nothing but 3a. Now a is equal to, we are going to bring this 3 on the right hand side. Since it is multiplied with a, when come in the right hand side it comes in the denominator. So 75 divided by 3, we know that it is equal to 25. So a is equal to 25 degrees, and what they have mentioned, it is 2a is 50 degrees, which is an acute angle, less than 90 degrees, which is acute angle. Okay, that is acute angle, right? And the problem we have in the SA1, what they have asked in this paper, that is section 3, they've asked for 4 marks question in the from the trigonometric chapter. Okay, they have asked problem number 14 B. They have asked to show that secant theta plus tan theta minus 1 divided by tan theta minus secant theta plus 1, this is equal to 1 plus sin theta divided by cos theta. That is what they are asking to show, that prove it is. Okay, so we start with LHS here. LHS, it is nothing but secant theta plus tan theta minus 1 whole divided by tan theta minus secant theta plus 1. Okay, so secant theta we can write it as 1 by cos theta, tan theta we can write it as sin theta by cos theta minus 1. As usual we are going to write. This way we can solve and take the LCM, and further we can simplify, but this is going to be little typical. This way you can solve, but we can use the trigonometric identities, and using that very easily we can find the proof for this. That is how we will see. Now we have, or we know that, we can write it as WKT, means we know that 1 plus tan square theta is equal to secant square theta. Now bringing this tan square theta on the right hand side, we can write 1 is equal to secant square theta minus tan square theta. 1 is equal to secant square theta minus tan square theta. So in the numerator of the given problem of LHS, this 1 we are going to replace with secant square theta minus tan square theta. Already we have here secant theta plus tan theta, that we keep as it is in the LHS. Secant theta plus tan theta, in place of minus 1, minus of, we write it as secant square theta minus tan square theta whole divided by, we have tan theta minus secant theta plus 1. So now in the numerator we have secant theta plus tan theta minus secant square theta minus tan square theta. So this secant square theta minus tan square theta we can consider it as a square minus b square. A square minus b square, and we know that a square minus b square is nothing but a plus b into a minus b. A plus b into a minus b. Here a is nothing but secant square theta minus b is tan theta, so b square is tan square theta. So we can write in place of a it as secant theta plus tan theta into secant theta minus tan theta. So 1 we can replace with as secant theta plus tan theta into secant theta minus tan theta. Okay, so now LHS same we have. We're going to substitute in place of this secant square minus tan square theta. So we have secant theta plus tan theta, it is already there. In place of minus 1, we can write it as secant theta plus tan theta into secant theta minus tan square theta. Okay, so minus of secant theta plus tan theta. This many times only for your understanding I have written the formula. You can directly write this in the numerator. This is secant theta minus tan theta. Little clumsy it is begin. I will write again. So in place of 1 we can write it as secant theta plus tan theta into secant theta minus tan theta. Okay, secant theta minus tan theta. Okay, in the denominator we have it is, we have not changed anything in the denominator. We are not going to disturb the denominator. We keep it as tan theta minus secant theta plus 1 as it is. Now if you observe the numerator, secant theta plus tan theta. Here we have the first term. After minus we have again secant theta plus tan theta into secant theta minus tan theta. So in the numerator from both the terms we can take it as secant theta plus secant theta plus tan theta. We can take it out common. So we left with as 1 in the first term, that is in this place we left it as 1, and in this place we have secant theta minus tan theta. In the denominator as it is we have tan theta minus secant theta plus 1. So if you observe here, this term, that is 1 minus secant theta minus tan theta, this minus we take inside the brackets. So what we get is secant theta plus tan theta as it is, secant theta plus tan theta as it is we have. In the second term 1 minus secant theta minus tan theta becomes plus tan theta whole divided by tan theta minus secant theta plus 1. So if we observe here, this 1 minus secant theta plus tan theta, and here also in the denominator we have 1 minus secant theta plus tan theta. Order is just changed, there will be no problem here, both are same terms. 1 minus secant theta plus tan theta in the numerator, and in the denominator it is 1. Here we have minus secant theta plus tan theta. So both the numerator and denominator are same. So we can cancel this. So what we left with it is here secant theta plus tan theta. Secant theta plus tan theta, that we can write it as, in place of secant theta we can write it as 1 by cos theta. In place of tan theta we can write it as sin theta by cos theta. Now if you take the LCM for this, cos theta is the LCM. This cos by this cos, it is 1. 1 into this 1, it is 1 we get, okay, plus this cos divided by this cos, it is 1. 1 into sin theta, it will be sin theta. Therefore we got it as RHS which they have asked. Hence we can write that, hence it is verified, or hence it is shown, hence it is shown the required answer. Thank you very much for watching. Please subscribe and share.